Welcome to the UNV Certification Program. The topic of this video is Basic Knowledge of IPC. After you have learned this course, you will realize the advantages of IP, be familiar with basic knowledge and working principle of IPC, as well as be able to choose IPC for different scenarios. Let's start with the ease of IP. First, let's see how easy our IP solution can be, no matter its installation, configuration, or maintenance. In one word, easy from beginning to end. Because of PoE function, the wired IP solution can reduce the installation labor for cables and improve power supply efficiency. Our network cables up to 250 meters can greatly reduce the construction cost. After installing them, we can also get quick configuration without difficult IP configuration. For example, for our PoE NVR, what you need to do is only one thing: connecting cameras to NVR with cables, and then we can see the image at once. Then, we also have to think about whether future maintenance is easy, and I'm glad to tell you IP system is very friendly for future maintenance. Suppose you are in your holiday, and suddenly your important client call you to make his cameras work as soon as possible. For analog cameras, you need to go to site, check and fix the problem, right? However, IP solution allows remote check, upgrading and maintenance. You can solve the camera's problems anywhere with the help of the internet. After knowing the advantages of IP solution, now let's see how IP cameras make it. We will focus on the basic knowledge of IP system and IP cameras. A video security system is a system capable of capturing images and videos that can be compressed, stored, or sent over communication networks. It's mainly composed of front-end, recording, and search and display parts. IP camera is one kind of front-end products. Recording and search part mainly includes back-end products, the NVR or DVR, which can store videos. We also can have VMS as storage device. If you want to manage perfectly your entire video system, you can seek help from the VMS. A decoder can make encoding capability of your system better. The display part is the monitor for you to view videos. So, as a front-end product, what is the difference between the imaging principles of IP cameras and analog cameras? First, for analog cameras, when light comes in, it enters the lens first. According to the imaging principle of light, a focal plane will be generated on the sensor at this time, and the sensor will convert the optical signal, that is, the continuous analog signal, into an electrical signal, and then process the electrical signal through DSP, digital signal processing, such as noise reduction, etc. After processing, the digital signal is converted into analog signal, and then output through the CVBS interface. In the whole process, the path from light to the video stream will involve two conversions between analog signals and digital signals, which will lead to two information loss, because the analog to digital conversion will inevitably cause information loss. Then let's look at the IP camera. After the light comes in, it will also focus on the sensor. The sensor will also convert the analog signal into an electrical signal, process it through DSP, and transmit the network signal. After the transmission, the video picture will be obtained directly. From this we can see that compared with analog cameras, IP cameras have one less DA process, so more information can be retained, and due to different ages and technological progress, the DSP technology of IP cameras is also more mature, which can provide higher quality images. Now let's take a look at the components of IPC. Inside it, there is lens. It collects light signals from the subject and images them to the photosensitive area of the camera through a series of optical glass lenses, which is the eye of the surveillance camera. There is also infrared light board. It is generally placed near the front face of the camera. It can emit infrared rays to irradiate objects, and the infrared rays are diffusely reflected and received by the surveillance camera to form an infrared image. There is also sensor board. Sensor is one of the core components of the camera, responsible for converting the optical signal passing through the lens into an electrical signal. It is also worth mentioning the coding board. It mainly integrates a SoC chip, which is responsible for image digital signal processing, including image processing, video analysis, and so on. In addition, the camera contains more than heatsink sheet metal, triaxial support, power board, and so on. Okay, now we know how the camera collects image like human eyes. For image collecting performance, we have image features and intelligent features. We will start with the image features. It is very important for a camera to take great quality images in no matter what conditions. First, let's take a look at resolution. The quality of image can be described by resolution. All digital images are made up of the smallest individual component, called pixels. Each pixel has a specific color and intensity. The total amount of pixels in an image is referred to as the resolution. At a higher resolution, you can see the camera can capture finer details in the scene, as shown in the image. However, higher resolution also leads to larger requirements of storage space and transferring bandwidth. For some application scenarios requiring more image details, you should adjust your camera to higher resolution. Now, let's see what the WDR function can do. When the high brightness area under intense light irradiation and the area with relatively low brightness exist in the image, the output image of the camera will appear bright due to overexposure to white, while the dark area will be black due to underexposure. Some cameras feature a WDR mode. It is a technology that can take two exposures in a single time, a long exposure to increase the amount of light entering the lens of the dark part, and a short exposure to reduce the amount of light entering of the bright part, thus delivering perfect image quality without detail loss in scenes with large brightness differences. Cameras also own various features to guarantee the image quality in low light environment. For example, the ICR cut. It is used to ensure the best results of the image both day and night. Let's take this picture as an example. It emits visible light and infrared light at the same time during the day. If we don't have a filter, the camera will collect these two kinds of light at the same time during the day, resulting in a purple color of the picture. So we need to use this ICR cut to block the infrared light to ensure the imaging effect during the day. At night, the visible light will become little or no. At this time we need to turn on the ICR cut to let the infrared light enter the lens to ensure the nighttime imaging effect. People have never stopped chasing quality imaging even in darkness. Therefore, in addition to black and white images, people also want to see color images at night. That's why the Light Hunter technology has been born. From the perspective of hardware, large size of sensor increases sensing area. Large aperture let more light enter camera, so generated image is brighter. From the perspective of the intelligent algorithm, the ISP technology make cameras apply smart gain control, auto nonlinear image enhancement, multiple exposure and 3D DNR, which means digital noise reduction and other technology to optimize the image quality in night. Therefore, with Light Hunter technology, we can see clear color images at night no matter indoors or outdoors. Optimized image effects provide us with more detailed information, such as colors, fonts, objects, etc. At the same time, the detection accuracy of intelligent function is also improved, because the detection accuracy is positively correlated with image quality. The clearer the image, the higher the accuracy of intelligent detection. Next, let's take a look at the common smart functions of our cameras. Let's take two functions as an example. First, let's understand the SIP function. Compared with traditional motion detection, our SIP function can perform model comparison on detection targets through deep learning algorithms and accurately distinguish pedestrians, motor vehicles, and non-motor vehicles. That is to say, only when the comparison is successful, the alarm will be triggered, which greatly improves the accuracy of detection and avoids false alarms caused by fallen leaves, small bugs, and other objects. At the same time, it also supports classified retrieval for different targets, which greatly improves the retrieval efficiency of specific videos. In addition, our deep learning also supports the function of video metadata. Cameras with this function can extract different attribute data in the video, such as the color of the clothes of pedestrians on the road, the license plate number, and other information, so as to improve the retrieval efficiency and help us to accurately retrieve a specific target. In the last part, we will together check the real application of suitable IP cameras in different scenarios. First, from the perspective of IP cameras features, cameras with WDR function can deal with strong backlight in the areas near entrance or window. LightHunter technology can make IP cameras have great performance under dark environments. For example, it can be used in the dark mountain road and city road to ensure the safety at night. And for intelligent functions such as SIP and video metadata, they can satisfy specific requirement of security. The SIP function can be used in any areas where entry or exit is prohibited, such as private residences, prisons, scenic spots, dangerous areas of factories, etc. Some of our cameras can not only accurately detect intrusion targets, but also warn and deter them to reduce the crime rate at night. Through the linkage of multiple IP cameras, the video metadata function can be used to solve problems such as finding missing people or missing vehicles, so as to ensure the urban safety. What's more, IP cameras have plenty of appearance for various requirements in installation scenarios and locations. For example, Bullet is usually used in most of outdoor scenarios, and Domo is preferred in most of indoor scenarios due to its small size. Fisheye is designed for large indoor scenarios because it can provide wide field of view. What if we want to have a large view in outdoor environment? We can select PTZ cameras. It has a field of view of about 360 degrees and a focal length that can be zoomed in a large range, allowing us to see wider and farther outdoors. In summary, in this course, we've talked about the advantages of IP, the basic knowledge and working principle of IPC. And we also learned how to choose IPC for different scenarios. That's all for the basic knowledge of IP camera. Thanks for watching. See you next time.